Welcome to the deep dive. Today we're diving into something pretty big. Um, AI long-term memory. Like how we use what we learned years ago to make decisions today.
It's a big challenge for sure. But there's this new research paper from Google Research called Titans, Learning to Memorize at Test Time, that's making waves.
Oh yeah, I read that one. It's fascinating. So much of AI right now is focused on the short term, right? Like what's happening right now in the data.
Exactly, like those transformer models. They're amazing at processing information in a certain window, but ask them to remember something from way back.
Forget about it.
Pretty much, they hit a wall. It's like trying to write a novel and only being able to remember the last paragraph.
Yeah,
You need that bigger picture, the context from earlier chapters.
right. It's all about context.
Mhm.
And I guess traditional AI models just weren't built for that kind of long-range thinking.
Well, they rely heavily on attention, which is great for focusing on relevant information. But computationally, it gets expensive fast when you're dealing with tons of data.
So it's like trying to have a million conversations at once. Your brain just can't keep up.
Exactly. And that's where this Titans research comes in. They've proposed a whole new family of models.
And they take inspiration from the way our brains work, with short-term memory for immediate stuff and long-term memory for the really important things.
They're combining those two types of memory.
Okay, so how does the AI actually decide what to remember? What goes into that long-term memory bank?
That's where things get really interesting. They're using something called the surprise factor.
Surprise.
Yeah, basically, the model measures how much its predictions change when it encounters new information.
I'm not sure I follow.
Okay, so imagine the model is trained on a huge data set of text, right? And it comes across a sentence like, the cat walked the dog to the park.
Uh-huh. Okay, I see where this is going.
Based on its existing knowledge, the model might predict that the dog is walking the cat, but then it sees the actual sentence and it's like, whoa, wait a minute.
Cats don't walk dogs.
Exactly. That's the surprise. That's the signal that this is something worth remembering because it violates its expectations.
It's like when you see a magician pull a rabbit out of a hat. You're surprised, and you never forget it.
Exactly. So the model is constantly learning, refining its understanding of the world. And those memories, those surprises are what stick.
That's so cool. But I mean, our brains can't remember everything, right? There's got to be some kind of filtering going on.
Absolutely. And Titans have a mechanism for that too. It's called forgetting.
Makes sense.
Yeah.
Otherwise, it would be like hoarding every piece of junk mail you ever received.
Exactly. But the forgetting isn't random. It's actually designed to mirror something called weight decay.
Weight decay.
It's a process used in training AI models to prevent them from overfitting to the training data. And it turns out to be a super effective way to manage memory in Titans, too.
So it's all about remembering what matters.
Precisely. And that's crucial for AI that needs to learn and adapt over long periods.
This neural memory you're talking about, it's more than just a storage space, right?
Oh, yeah, it's way more. It's actually a meta model.
A meta model.
It doesn't just store information. It learns how to memorize based on the task it's given.
Whoa, that's a game changer. It's like having a personal librarian in your brain who knows exactly how you like your information organized.
You got it. And that adaptability means Titans can be used for a whole range of AI tasks.
So they can learn to optimize their memory strategies on the fly.
Exactly. Now, the researchers actually created 3 variations of Titans, MAC, MAG, and MAO.
Oh yeah, I was just about to ask about those. They each use long-term memory a bit differently,
Okay.
right? Like different tools in a toolbox.
Exactly. So MAC, which stands for memory as a context, uses long-term memory to give the model background knowledge.
So it's like having a massive library of information that the AI can consult whenever it needs to understand something better.
Exactly. Then there's MAG, which stands for memory as a gate.
And what does that one do?
MAG uses long-term memory to control the flow of information from the short-term memory.
So it's like a bouncer at the door of your memory, only letting in the important stuff.
I like that analogy. And then we have MAL, which stands for memory as a layer.
Okay, and how does MAL work?
MAL incorporates the long-term memory as a layer within the whole model architecture.
So it's like having a built-in advisor who's always whispering in your ear, guiding you based on past experiences.
Exactly. So you've got these 3 different flavors of Titans, each with its own way of using long-term memory.
So pretty impressive.
Yeah.
But how do they actually perform? Can they walk the walk?
Oh, they can definitely walk the walk. The researchers put these models through their paces.
Tell me about it. What kind of tests did they run?
They tested them on tasks that are known to be really tough for AI, especially tasks that involve long sequences of information, like language modeling, common sense reasoning, even something called needle in a haystack challenges.
Needle in a haystack. That sounds intense. What is that?
Imagine you have a document that's thousands and thousands of words long, and you need to find one specific piece of information buried in there.
Like finding a single grain of sand on a beach.
Exactly. It's a test of how well an AI can sift through massive amounts of data and pinpoint exactly what it needs.
I can see where a good long-term memory would come in handy for that. So how did the Titans do?
They aced it. They consistently outperformed existing models, especially when it came to tasks that involved remembering information from way back in the data.
So they're not just theoretically interesting. They're actually good at what they do.
Oh, yeah. They're the real deal. And what's even more impressive is that they achieved these results with fewer parameters than some of the competing models.
So it's not just about brute force computing power. It's about having a smart and efficient memory system.
Precisely. And that's what Titans bring to the table. They've changed the game.
This is blowing my mind. It's like we're moving away from those clunky robots in sci-fi movies and towards something much more sophisticated.
I agree. This research really does push the boundaries of what we thought was possible with AI.
But all this talk of deeper memory and complex processing makes me wonder, is there a downside? Does all this come at a cost?
That's a great question. And the researchers definitely addressed that. It's true that deeper memory models need more computational resources during training.
But does it make the training process significantly slower?
They found that the increase in training time was linear with memory depth, so it's manageable and predictable.
Okay, so it's not like adding more memory suddenly makes the training process take forever.
Exactly. And in fact, Titans had competitive training speeds compared to other state-of-the-art models, even with all their fancy memory capabilities.
That's good to know.
Yeah.
It means this approach isn't just a pipe dream. It's actually feasible. So it sounds like Titans have a lot going for them. But before we get carried away, I think it's important to really understand how they work their magic.
I agree. We've talked about the general principles, but let's get into the specific.
Exactly. I'm really curious about those ablation studies they did. Where they took the Titan models apart piece by piece to see what made them tick.
Oh yeah, the ablation studies. Those are fascinating. It's like they were playing AI Jenga, pulling out different blocks to see if the whole thing would collapse. And what they found is pretty amazing. Every component they tested actually played a role in the model's success.
No freeloaders in these Titans.
Exactly. But some components were more crucial than others. Like they found that if you remove the forgetting mechanism, the performance takes a hit.
Makes sense. If you can't clear out the clutter, the less important memories, it's going to get overwhelming.
Right. It's like trying to learn a new language but never forgetting any of the words you've ever heard. You'd be overloaded.
So forgetting is actually key for effective learning. Who knew?
It seems that way. And they also found that things like the momentum and the surprise, measure the convolution layer, and the persistent memory all played important roles.
Like a delicate balance.
Exactly. Tweaking any of those things led to a drop in performance.
Interesting. So what about those different architectural variations of Titans? MA, MAG, and MAL. Do they all perform the same in the ablation studies?
They did not. For things like language modeling and common sense reasoning tasks, MSc and MAG were pretty neck and neck.
Right.
But when it came to those really tough needle in a haystack tasks, MSc was the clear winner.
So MC is the one for handling those really long stretches of information.
Exactly. And remember how we talked about ML being the fastest when it came to training?
Right. So it's like speed versus power.
Exactly. The best choice depends on what you need it for.
So all this is great. But how are these Titans actually being used? Are they just a cool research project, or are people putting them to work?
Oh, they're definitely being put to work. Remember how they can handle tons of data and find those needles in the haystack? Well, that makes them perfect for things like legal research.
Yeah, I can see that lawyers spend so much time digging through mountains of documents.
Right. And with Titans, they could potentially find those crucial precedents and clauses so much faster and maybe even more accurately.
That would be huge. What other areas are benefiting from Titans?
Well, they're also showing promise in things like financial modeling and market analysis.
I can see how they'd be useful there. To predict market trends, you need to analyze massive amounts of data.
Exactly. And Titans can sift through all that noise, find the important patterns, and make better predictions about the future.
It's like having a superpowered memory that can instantly recall every relevant financial event from the past century.
It's not quite magic, but it's pretty close. What about applications beyond the business world?
Yeah, are there any ways Titans could be used to solve, like social or scientific challenges?
Definitely. One area that's really exciting is medical diagnosis.
You mean like an AI doctor?
Not to replace human doctors, of course, but to help them. Imagine training a Titan model on a huge data set of medical records, symptoms, test results, treatments.
It could be like having a consultant who's seen every case in history.
Exactly. It could help doctors consider rare conditions, identify subtle patterns, and personalize treatment plans.
Wow, that's incredible. But it also raises some concerns, right? Like if these models are trained on sensitive personal data, how do we protect that data?
That's a huge question, and one that researchers are taking very seriously. Issues of data privacy, security, and bias are all crucial considerations.
Absolutely. It's a balancing act for sure. But let's not forget the incredible potential here. AI could help us solve some of the world's biggest problems.
I completely agree. It's a really exciting time to be working in this field. So we've talked about the benefits of Titans, but what about their limitations?
Yeah, are there any areas where they struggle or where this approach might not be the best fit?
Well, one thing is that they still need a lot of data to train effectively.
Right.
Yeah.
That's like us humans. We need a lot of experience to develop a deep understanding of the world.
Exactly. So for tasks where data is scarce, Titans might not be the ideal solution.
What about the computational cost? We talked about how training time increases as you add more memory.
Right. There's always a trade-off between memory capacity and computational efficiency. It's about finding the right balance.
Makes sense. And what about the surprise mechanism? Could relying on surprise lead to bias?
That's a good point. The researchers acknowledge that the surprise mechanism could potentially amplify existing biases in the training data.
So we need to be extra careful about the data we use to train these models.
Absolutely. But even with these limitations, Titans are a major step forward in AI. They give us a whole new way to think about how machines can learn and reason over long periods.
It's like we've given them a superpower, the ability to learn from the past in a way that was never possible before.
Exactly. And as with any superpower, it's up to us to make sure it's used for good. But before we dive into those ethical considerations, let's circle back to the depth of memory in these Titan models. We mentioned that deeper memory tends to lead to better performance, but is there a limit?
Yeah, is there a point where adding more memory layers doesn't really help?
That's a great question. And the researchers actually did some really cool experiments to figure that out. They tested out different memory depths, ranging from 1 to 4
What did
layers.
they find?
Well, it turns out deeper memory does help, but only up to a point.
So like adding more RAM to your computer, it only helps so much.
Exactly. After a certain point, adding more memory layers didn't really improve performance, but it did increase training time.
Ah, so it's about finding the sweet spot. Too much memory and you're just wasting resources.
Right. But what's cool is that even with relatively shallow memory depths, these Titans models were still super effective.
It's like they've cracked the code on efficient memory management.
It's not just about storing a bunch of information, it's about processing it, understanding it, and prioritizing what's important.
Right. It's the difference between memorizing a textbook and actually understanding the concepts.
That's it. And that's what makes Titans so special. They're not just storing data, they're learning and adapting constantly.
This is really making me rethink the possibilities of AI. It's like we're opening up a whole new world of potential applications.
Absolutely. Imagine AI assistants that remember everything you've ever told them. AI scientists that can sift through decades of research data. AI artists that can draw inspiration from centuries of art history.
It's like giving AI a sense of history, a deeper understanding of the world.
Exactly. And that could lead to breakthroughs in every field imaginable. Medicine, education, entertainment, you name it.
This is incredible. I can't wait to see what the future holds for this technology.
Me neither. It's a really exciting time to be working in AI.
Well, we've covered a lot of ground today. It's been a fascinating deep dive into the world of AI memory.
I agree. And I hope our listeners have learned a lot about these amazing Titan models and the future of intelligent machines.
Thanks for joining us on the deep dive. We'll be back next time with another look at the cutting edge of AI research.
Until then, keep exploring.